Okay, so today we're going to be talking about solving systems of linear equations. So this is a system of linear equations. Basically what that means is you're going to have two different variables. So in this case you have x and y. Normally you'll be used to saying something like x plus 3 is equal to 5 and x equals 2. Now of course that's pretty simple, but that's normally just like a simple linear equation because it only involves one variable, but this time we're going to be using two different variables. So we have x and y. So to solve this, it's pretty simple. By looking at this, you can probably tell two numbers add up to 5, and those same two numbers subtract to give 1. Out of the top of your head, you could come up with maybe x equals 3 and y equals 2. So 3 plus 2 is equal to 5, while 3 minus 2 is equal to 1, and you kind of get the same thing. But it's not always this simple, so we're just going to try and solve this the proper way so that we can tell it easier. So to first solve this, you're going to want to number your equations, and what we're going to do first is subtract the two equations. So we're going to subtract 1 and 2. So I'll teach you how to do this. You have x plus y is equal to 5 and x minus y is equal to 1. This time, the number in front of our x and our x are the same, and they're also the same for our y terms. When it's the same, normally you can go ahead and just eliminate one variable. What eliminate means is you're getting rid of one variable. That's basically all it is. So in this case, you can see that your two x's are positive and your y is positive and your other y is negative. In this case, I would subtract. So what I would do is I would subtract the whole entire two equations. So x minus x gives 0. So we're just going to write 0. Y minus negative y, or y minus minus y, is basically positive 2y. Because if you think about it, it's y minus minus y, which is basically equal to y plus y, which is 2y. So that's basically 2y, and then if you subtract 5 and 1, you're going to get 4. So you can get rid of the 0 because zeros don't matter, and you'll get 2y is equal to 4. So then y is equal to 2 if you divide 2 by both sides. So now you know that y is equal to 2. Now it's pretty simple. All you're going to want to do is substitute this back into your equation. So into 1 or 2 doesn't really matter. I'm just going to substitute it into 1. So you have x plus y is equal to 5. You're going to substitute that y equals 2. So x plus 2 is equal to 5. And if you subtract 2, you'll get that x equals 3. So the solution to this system would be 3, 2. So basically you're writing it like x comma y, like coordinate points kind of, and on like a graph. So it's going to be 3, 2. If that's too complicated, you can always write it as x is equal to 3 and y, I don't know why it's not writing, y is equal to 2. So this would be your two solutions. So now we're going to be doing another example. In this example, we can see that none of our x or y terms have the same coefficient. So here we have 2 and 4, and here we have 3 and 5. So as you can see, nothing is the same. So in this case, what we're going to want to do is make one of our equations, so either equation 1 or equation 2, equal to the other. Now that doesn't make much sense, but basically all we're doing is taking one variable. In this case, I'm just going to use x. So in front of x we have 2. And we want to make it 4, or we want to make 4 2. In this case, it'd be easier to go from 2 to 4 because you can just multiply by 2. Now, always note that you have to multiply when you're changing, you cannot add. So we're going to multiply by 2. So that means we're just going to multiply the whole of equation 1 times 2. So 2 times 2x minus 3y equal to negative 19, so the whole thing. Now, if you expand that, you'll see that the answer you get is 4x minus 6y equals negative 38. So basically all I did was expand by multiplying 2 with each term. Okay, and I did not change any of the signs. So now next what we're going to want to do is bring this next equation down. So it's 4x plus 5y equals 17. So now basically what we're doing is we're going to solve this equation set. So since they both are the same value, so in front of the x you have 4 and 4, we're just going to subtract. Now, make sure that you don't add both of them. If you add both of them, you'll see that you'll get 8x, because 4x plus 4x is 8x. You're not going to get rid of any variable. To get rid of a variable, if you subtract, you'll get 0x, which is what we want, because that gets rid of it. Next, so you're going to do this vertically. So first 4x minus 4x, and now we're going to do negative 6y minus 5y. So it's negative 6y minus 5y. So we're going to get negative 11y. So we're going to put that here, negative 11y, which is equal to negative 38 minus 17. So that would equal negative 55. And as you can see, we can omit the 0x because it's basically the same thing as just 0. So if you solve, you see we have negative 11y, which is equal to negative 55. If you divide both sides by negative 11, you'll get y is equal to 5. Your answer is y is equal to 5 for y. Now, to find what x is equal to, you're going to want to substitute it back at the beginning. So in the beginning here, we have two different equations, and you're going to substitute this answer, so y is equal to 5, into one of them. So let's do it into equation 2. Equation 2 is 4x plus 5y is equal to 17. If you substitute y is equal to 5, you'll get 4x plus 5 times 5, which is equal to 17. So 4x plus 25 is equal to 17. Subtract 25, you'll get negative 8. And divide both sides by 4, you'll get negative 2. So that means x is equal to negative 2. X is equal to negative 2. That means your final answer for this question is x is equal to negative 2 and y is equal to 5. So we have two different solutions for this. So one solution for x and one solution for y. And that's how you solve systems of linear equations.